Awesome. Well, thank you. We're here to talk about workforce directory authentication and modernization at scale. I am Megan Fodder. I'm a distinguished engineer at Home Depot. I have the privilege of leading a team of architects and principal engineers who support our identity access management space for workforce and consumer, for non-employee workforce. They dabble in governance, risk, and compliance, and they also sit on our review board and inspect our enterprise solutions for adherence to our cybersecurity controls. Really excited to be here today to talk with you all. One of the reasons that Home Depot loves to come to these conferences and share what we've been working on is to make connections with our colleagues and partners, and so would love to connect with each of you on your journeys and understand your architecture kind of as a follow-up to this session. So start with a question. It's a question we ask ourselves a lot at Home Depot. What could the workforce experience be? What should it be? What is your experience when you use technology outside of work? And what capabilities do we have today with our modern stack that we can leverage to improve that experience? So that experience could be passwordless. And passwordless is amazing because it's this magical place where we get to have both cybersecurity controls and a good user experience. And that experience should be consistent. We know at Home Depot that when we hire a store associate, the time between the point when we hire that associate and we can onboard that associate, the faster that time is, the more likely that store associate is to make it to the 90-day mark of employment. It's really important to us. So we want a really consistent experience. We want our experience to be adaptive. We want less friction when there's less risk, and more friction when we think that the interaction is risky. And we want the experience to be resilient. Today, during Cisco's keynote, Matt Caulfield mentioned that identity is critical infrastructure, and we believe that as well. And so we strive to provide that resilient identity architecture. And you may wonder, well, why isn't it? Why don't we have all those things? We're at Identiverse, it's amazing. There's all these vendors here, all this technology. Why don't we have passwordless? Why isn't it consistent? Why are we having trouble with resiliency? So today, we'll talk some about that. We'll talk about a really specific use case for store workforce and how they interact with hybrid distributed applications. We'll talk about the current state, which is very complicated, and what it means to modernize. I'll share our simplified target state architecture, and we'll talk some about how that's going to improve user experience. This is an architecture work in progress, so some of these things have been prototyped, and some of them are in production today, and some of them are currently being baked out. So it is a work in progress, what you'll see. So to start with the use case, we have at Home Depot, 95% of our applications are developed in-house. We have thousands of developers. We like to consider ourselves a semi-technology company. And those in-house developed services, they are in hybrid distributed runtime today. That means that we have components that are running in our on-prem data centers. We have components in private cloud. We have an on-prem private cloud with components and services. And we have a store footprint, a legacy store footprint. But we also have a lot of requirements that we have to meet. High availability. We have to meet service interoperability. And we have this really interesting use case where we have to run critical applications disconnected in our stores. So we're also talking about scale. We have 2,337 stores, over 400,000 associates, and that's just in our workforce. We have 3,000 technology solutions. To us, a solution is an entire ecosystem. So those 3,000 technology systems, solutions, that's tens, thousands of services and subservices that interact. And we have 13 unique hosting environments. So how did we get here? Hybrid processing reflects for many of us, including Home Depot, our journey through technology. We started in a highly decentralized architecture. That's where Store associates only ever interacted with applications that ran locally in the store, and the stores could run primarily disconnected from any central processing. In that decentralized architecture, we built a service layer to help enable applications to interoperate. And those were in-house built services. And then we've moved to like a centralized service-based architecture. So the primary drivers of that, I'm sure we've all been there, SOX compliance, PCI. It's easier to comply when things are centralized. And technology also has kind of forced that centralized service-based architecture. And in this architecture, we started to build out Tomcat environments running in our data centers, running in our stores, and a service level that supported interoperability in those Tomcat applications. And that interoperability, it was primarily focused on service interoperability, not really human security. And that brings us to the hybrid distributed architecture of our current state. And this is where we have components that are running everywhere. We have applications that have services running in our data center. We have cloud services. All of our e-commerce is in GCP. Most of our applications have been moved to GCP. We still have that legacy store footprint. But what we've carried forward as we've gone through these architectures is the need to have this disconnected processing in our stores. It's very important to our business at Home Depot that we can do critical sales and returns in an offline or disconnected state. And that was a lot easier in that decentralized architecture model, and is a bit of a challenge in the hybrid model. So the hybrid model was pretty good for a long time, but what we've seen is we've seen a need for store associates to access more technology solutions to do their job. Those solutions don't run in the back of the store anymore. They run in the cloud. They are SaaS applications. We've seen expectations from our store associates that their experience at work is similar to their experience with technology outside of work. We know that employee commitment, our employee commitment index, I don't know if any of you do these surveys with the employee commitment index, we know that the associate's experience at work with technology impacts their commitment index. So what does this hybrid architecture result in? It results in something we call lots of logons. So we've got this really complicated state, and as you can see in the complicated state, we still have components. We have components from our decentralized architecture, we have components from our centralized architecture, now we have hybrid components. And these things do not interoperate well, and it's a poor user experience. Now, this is a good time for me to remind you, Home Depot Public Relations and Investor Relations has asked me to share that these are not actual architecture diagrams. This is not our actual architecture. They want me to explain that we don't have any Band-Aids on any of our technology, not in our data center, those are not real Band-Aids. Those are hypothetical, conceptual Band-Aids there to help convey a point. So we're here. How do we modernize? What are we going to do? How do we make these services interoperate better? How do we provide a better user experience? So for us, we think that the first step forward is to implement a highly available performant data layer. The data is the most important part. It's the foundation on what we're going to build on. We need to consolidate our authentication and directory services to reduce our technical debt and our operational overhead. More importantly, the level of complexity that we have today makes it really hard to troubleshoot problems and maintain the levels of availability that we need to maintain. And we're going to migrate to modern authentication solutions and protocols. That's OAuth and OIDC. And we're not just going to do that. We're going to use the open source libraries so that we can avoid any kind of vendor lock-in and ensure that our applications interoperate well. So our simplified target state. That looks like a data and directory layer built on Radiant One directory. We currently use the Radiant One product to aggregate our store LDAP, our corp LDAP, our Active Directory. We point our IDP to that, and that gives us a pretty good, mostly single sign-on experience. But we're going to go one step further. We're going to replace those legacy directories of Radiant 1, and we're going to improve the resiliency of that environment. We're going to migrate to the OAuth OIDC standards. We're moving to a cloud SaaS central IDP with an in-house built store IDP for that disconnected processing, and I'll show you some diagrams of that in a minute. Authorization. So, like many of you, I don't know if we talk about it enough, we're getting killed by account takeover. And so for us, there's a couple of ways that we can mitigate account takeover. But in our target state architecture, we're going to invest more in authorization, not just the coarse-grained authorization that we can get with our Radiant 1 directory. We'll build out a fine-grained authorization system. We haven't determined what that architecture looks like yet, so we're still kind of baking that. And we've built a service mesh. So our service mesh is built on Envoy, which is an open source project. We're using that to obfuscate the IDP and the directory from the applications so that we can point those applications to our Envoy proxy and migrate the components behind that proxy in a way that is seamless and not impactful to our development community. And that's what this looks like. Again, conceptual, hypothetical diagram. This is our directory hub architecture. So we're installing the Radiant 1 directory at our edge. So for us, edge means Equinix. So that will run on bare metal and Equinix. We're installing it in our private cloud, and for that means Google. So we'll run Radiant 1 in Google, and it means our data center temporarily as we migrate out of the data center over the next 10 years. It also means that we have spokes. So there's the central component of the directory, and there's the store spokes. So we'll have a directory in every store. This will replace our legacy LDAP directory. And this gives us a lot of advantages. It gives us a new identity data fabric that we can build on. We have some thoughts about building our zero trust engine on this. We already have an authorization, an Auth0 service that is built on this. Today, we have an identity data warehouse that we custom built. It is supporting our IGA platform, which is SailPoint. We think that we can move a lot of functionality from our in-house built IDW solution into Radiant 1, kind of simplify our stack. We're also hoping that we can improve replication of identities between our core solution and our cloud services. Probably use cases for another day, but today it's taking us, 20 hours to replicate to GCP and in some cases Azure, and that's just not a great development experience. And so we're hoping that we can leverage our Radiant 1 central directory to improve the replication of identities to our cloud providers where needed. This also will give us reconciliation capabilities. So today we have our on-prem and our store directory, and we have the ability to add users directly to our store directory. I don't know if any of you were in Justin's talk yesterday about like federation bubbles, and he talked about the bubble and the other bubbles. I don't know if anyone saw that. It was a really good talk. This is an example of a federation bubble-like architecture, but we do have the ability to reconcile back to our central directory. We don't add a lot of identities in that offline state, but it's great that we can reconcile them back to the hub. And this is what the store directory will look like. This is our directory spoke. So in order to modernize our applications, the main blocker is that we don't have an OAuth OIDC provider in the store. We have an LDAP provider in the store, and we have some of those local technology components that we built ourselves servicing our store applications. So in order to move forward, we're building out a lightweight OIDC OAuth provider. We've prototyped and POC'd Dex IDP, another open source product. And we think that this will be the choice for that layer. We're building our own proxy so that in typical processing, we can process through to our cloud SaaS IDP. But then in that disconnected use case, we can fail back to our local provider. And that's where our directory becomes very important, because that's required to support those offline use cases and be able to switch from offline to online processing. This is a real example. So I wasn't allowed to put it on the slide, but this is our returns application. So I don't know if anyone has shopped in our stores. The previous user experience for a store associate was to log on to the point of sale with their LDAP account and their password. And then that's a thick client on a Windows application. And then they were able to run legacy services in our stores, like point of sale returns, without having to re-authenticate. And that's because we built that really old service, some services on our local store environment to support that. As we've modernized the returns application, now the new returns application is called One Returns. And we're telling our store associates, hey, you're on the point of sale, launch a browser and go to this browser app, One Returns, where they have to log in with their account and their password. One Returns is an OAuth application federated to our, it uses our on-prem IDP. But One Returns isn't fully functional. One Returns has to call back to the store return service to complete the transaction. So when One Returns, running on-prem in our private Pivotal Cloud Foundry infrastructure, calls to the store, that store associate has to log in again. And there's no way we can fix this because the store authentication is yellow. It was from the original decentralized architecture, running as like a sidecar on the returns app on the point of sale. That will never interoperate with our modern applications, our modern web applications. So to unlock the path forward, this is a terrible user experience. This has got my store associates logging on 2-3 times to do a return. But maybe what is the impact of that? The impact of that is they don't want to use One Returns. They're going to just continue to use point of sale returns. So as we introduce new functionality, new capabilities in that application, they have no desire to use it. And they just keep asking for us to build those capabilities into the point of sale return, which we cannot do because we're trying to modernize these apps. So in order to support that offline processing mode, that's where that store transitional architecture comes into play, where we have a local OAuth OIDC provider, and we can provide the OAuth tokens, which can interoperate with our hybrid cloud apps. So some key takeaways, this is just one short use case, is that the data is foundational. We know that today where we have these disconnected use cases in a legacy directory. So we're going to build on that and ensure that the data is everywhere we need that data to be. And we're leveraging the Radiant One platform, which is a convenient way for us to manage that data. And it's an excellent way for us to extend that data for improved authorization. User experience is the key. This is effectively a presentation about a directory. We didn't talk too much about a directory. We talked a lot about the user experience of how users at Home Depot, store associates, interact with our applications. And I think that's really important. In the keynote on Monday, Andy showed like a new Venn diagram. Did you see it? Where you replace like identity with experience and put identity in the big box. So for us, I think that it's more the same Venn diagram with experience overlaid. But the experience of the user, of the customer, is really important. And then transitional architecture. What I've shown today is a work in progress. We can solve hard problems. This is a hard problem to solve. It might not be the best solution. We're going to iterate on it. We're going to test it. We're going to improve it. Maybe we'll come back next year and share where we are and what we've learned. But the transitional architecture is really important. And I want to really highlight that because I don't think we're ever done these days. And these days, with our rapid technology capabilities and the evolution, we're never done. Like, there's never a day I can wake up and say, like, it's done, it's finished, right? It's a day where we come in and we're like, it's done for today, and we have new capabilities, and we're just going to keep making it better. And so we're building these architectures understanding that, and we're building these foundations so that whatever happens, these things that I might not have anticipated, we can continue to adapt and build upon. So with that, I will say thank you and take questions. no one has questions? Yes?
I'm curious about the disconnected use case. Is that because of poor internet connections or just any kind of disaster that would break you from connecting to the cloud?
That's a great question. So the question was about the disconnected use case and if it was for poor internet connection or any kind of connectivity. It's very complicated. I have a long answer. So in the early processing, the disconnected use case was for when we were disconnected specifically from the data center. Home Depot, we have invested significantly in our store network. I think it's like 5 times redundant, and we're testing Starlink. It's ridiculous. We have so much redundancy in our connectivity that it's made us comfortable with that hybrid application architecture where we have components running in GCP or our cloud and in our store. So the disconnected use case comes into play a couple of different ways. Sometimes a store register, a point of sale, can't connect to the servers in the back of the store. So that we call that like a disconnected use case. And for that, we have a local authentication fallback. And we will always have that. We have disconnected when the store, for whatever reason, cannot access the internet. Even with as much redundancy as we have in place, it happens sometimes. And then we have those hurricane offline scenarios where we just have stores that need to be brought up in a degraded state. And in those stores, we have to do some critical business processes. We have to be able to we call it cash and carry. So we have to be able to take cash. We have to be able to process gift cards, checks, credit cards with floor limits. So that's a disconnected payment processing use case. And we have to be able to accept goods into the back of the store. Did that answer your question?
Yeah, so you're a critical service provider in a disaster like a hurricane.
Yep. Plywood, water, whatever it is. And we also have metrics. So we have metrics that show how much revenue we make in like a degraded state. And it is a significant, even if you take out the disaster scenarios, because those are horrible. I don't want to talk about making money from someone's misfortune. But the states where we might not be able to connect from a network perspective, we have some significant metrics on the revenue that we make. Mm-hmm. Yeah.
So the rating one solution that you are showing, how do you measure the performance SLAs or metrics for that?
Sure. The question was the Radiant One solution, so the Radiant One directory. How do we measure performance SLAs for that? So the architecture I've shown is our target state. In our current state, we do use Radiant One. We measure that through just transaction times. Like we have dashboards and expectations for the time it takes for an authentication transaction. We have we know how many transactions a month. It's over 1 billion. So we hit our Radiant One directory with over 1 billion transactions a month. And we have metrics on like the end-to-end flow of some of our processes, like provisioning. So that's how we're measuring it. But really just response time, and then we look at the critical factors like critical resiliency factors like sockets and system performance and that kind of thing. Good question. Any more questions? Well, awesome. Thank you so much for your time. As I said in the beginning, I would love to connect. So I'd love to hear from you. I'd love to hear if you all have had success with architecture similar to this, or you've had problems with it, or you don't think it's going to work. I'd love to hear about it, incorporate your feedback, and ensure that we're delivering the best possible solution. And I can't wait to come back and give you an update on how it's going with us. Thank you.